Hello there! Today we're going to talk about degeneracy in linear programming. Let's start off with the definition. Degeneracy occurs when a basic feasible solution contains a smaller number of non-zero variables than the number of independent constraints when values of some basic variables are zero and the replacement ratio is the same. Under simplex method, degeneracy occurs where there is a tie for the minimum positive replacement ratio for selecting outgoing variable. Let's take a look at some examples of degeneracy.
So an example of degeneracy given this equation, having an objective function of z is equal to 3x sub 1 plus 9x sub 2, subject to constraints x sub 1 plus 4x sub 2 is less than or equal to 8, x sub 1 plus 2x sub 2 is less than or equal to 4, and given two variables x sub 1 and x sub 2 is greater than or equal to 0. So, given these constraints, these inequalities, we have to turn them or to convert them into an equation. Also, we have to consider that these are less than signs, therefore we must insert a slack variable. So, therefore the equation would be x sub 1 plus 4x sub 2 plus slack variable 1 is equal to 8. X sub 1 plus 2x sub 2 plus slack variable 2 is equal to 4. And then given this objective function, we have to consider this one as well. Therefore, it will be z. We have to simply transpose these two variables. Minus 3x sub 1 minus 9x sub 2 is equal to 0. The next step would be to plot a table based on these new constraints. So the table would look something like, you simply have to consider the variables that are included within the constraints. Therefore, you have to get these values from here. So given x sub 1, this will be 1. X sub 2, its value is 4. S sub 1. It does not have S sub 2 within it, so therefore this one will be 0. And then considering the next equation, x sub 1, 2x sub 2, it only has slack variable 2, therefore the slack variable 1 will be 0, and this one will be 1. Also, these will go here. This one will be 8, this one will be 4. And then the equation below will be considered as well, in which x sub 1 would be negative 3, x sub 2 would be negative 9, and then it does not contain slack variables, and it is equal to 0. And z is equal to 0 rather. And then considering the lowest value below, which is 9, you will divide 4. It will divide 8 by 4, and we will divide 4 by 2. Therefore, both are equal to 2. Therefore, it is a tie. And then, in order to determine the pivot row, there is a technique to be discussed by the following video.
Okay, let's continue on. In our second tableau, we just simply swap S1 and S2 with X1 and X2. First, we're going to find our pivot value, which is, we're going to use this solution to find out our pivot value. So, S1 over X2. So first, 1 over 4, 0 over 2. So as you can see, this is simply 0 over 2 is the least or less number that we have. So that means 2 is our pivot. As you can see, this row is our vector. So this is simply row 1 and row 2. Now we have to make 2 into 1, or the number 1. With this formula, 1/2 times are 2. So we simply make times everything with 1/2. So first, we have our 0 times 1/2 is 0. 4 times 1/2 is 2. and then 0 times 1/2 is simply also 0. 1 times 1/2 is 1/2. 1 times 1/2 is also 1/2. And then 2 times 1/2 is equivalent to 1. Now, this is our new row 2. Next, we're going to find our new row 1 by with this formula. R1 minus 2 times R2. So as you can see here, this will make our row 1 into a new column. So R1 is 0. First, we have to times 2 times 0, which is our R2. So 0 times 2 is 0, minus 0 is still 0. 8 minus 2 times 4. So 4 times 2 is equivalent to 8. 8 minus 8 equals to 0. 0 times 2 is 0, plus minus 1 is still 1. So 1 times 2 equals to 2. 0 minus negative 2 is minus 2 is negative 2. Next, 1 times 2 is 2. 1 minus 2 is equivalent to negative 1. And lastly, we have 4 and 2. 2 times 2 is 4. 4 minus 4 is 0. This will be our new row 1. And this will be our new row 2. Now with that all aside, let us now proceed to the next tableau. Alright, this will be our last and final tableau. We just simply replace S2 with X2 so that we can get R9. So the 0 here was replaced by 9. Now we can solve for our minimum ratio. First, we're going to use these formulas. CB times X1, CB times X2, CB times S1, CB times S2. So 9 times 0 is 0. 9 times 1/2 is 9 halves. 9 halves, and then 9. Now, minus CJ. This is our CJ right here. So 0 minus 0 is still 0. 0 minus 9/2 minus 0 is still 9/2. 3, 9/2 minus 3 is equals to 3 squared. 3 halves, and then 9 minus 9 equals to 0. So this will be our new delta J right here. These guys right here. And now we can get our minimum ratio. So Z equals to 18. X1 equals to 0. And X2 equals to 2. Which is right here, guys. And that's it. Thank you for listening. I hope you enjoy, and God bless.
Second example of degeneracy. Given this equation, 20x sub 1 plus 10x sub 2 subject to constraint 8x sub 1 plus 10x sub 2 less than and equal to 240, 4x sub 1 plus 4x sub 2 less than and equal to 120, and these two variable greater than and equal to 0. So, given these inequalities, we need to convert this into equation. Also, consider this less than sign, we need to add the slack variable. So to write this, 8x sub 1 plus 10x sub 2 plus the slack variable equal to 240. Then 4x sub 1 plus 4x sub 2 plus the slack variable equal to 120. Also, for the objective function, 20x sub 1 plus 10x sub 2 plus 0 s sub 1 plus 0 s sub 2. Now, the first table, the basic variable will be these two slack variable. So s sub 1, s sub 2. The CB is 0, 0. The XB is the value of the these two equation. So 240 and 120. So for x sub 1, we will now put the variable 8, 10, 1, 0. 4, 4, 0, 1. For the z, to get the z, we need to multiply the CB and XB and add the S sub 1 and S sub 2. So 0 times 240 plus 0 times 120 equal to 0. Now for the CJ, it is the coefficient of the new objective function. So 20, 10, 0, 0. So for the delta J, CB times XJ minus CJ. So it will be negative 20, negative 10, 0, 0. For the pivot column, it will be the smallest value of the delta J. So this is the pivot column. So we need to divide this XB and X sub 1. So 240 divided by 8, 120 divided by 4. This will be equal to 30. So with this, we need to swap the slack variable with the x sub 1 and x sub 2. So for the next table, just copy the basic variable, the CB and XB, and also the coefficient of slack variable in x sub 1 and x sub 2. So S sub 1, S sub 2, 0, 0, 240, 120, 1, 0, 0, 1, 8, 4, 10, 4, C equals to 0, negative 0, 0, negative 20, and negative 10. So for the minimum ratio, we need to divide S sub 1 and X sub 1. So 1 divided by 8 and 0 divided by 4. So for the pivot value, it will be the 4, which is in the row 2.
Proceed to the third tableau. In the third tableau, we need the constants in the pivot column to be 0. So, before that, we need to subtract the R1 by 8 times of R2 and the R3 by adding it to 20 times of R2. In the result of that, because it is already 0, so we will put it here as 0. And then the other one, 240 minus 8 times of 30, which is 240, will result also into 0. While R1, which is 1, minus 8 times of 0 is 1, and then after that, the 0 minus 8 times of 1/4 will result into negative 2. And then R1, which is 8, minus 8 times of 1 is what is 0. And then lastly, R1 minus 8 times of 1 will result into 2. After that, the result was already given. X sub 1 is now 30, x sub 2 is 0 because you cannot get the x sub 2 and then the slack variables are also 0. Then 20 times 30 will give you 600. So z is equal to 600.